Hello everyone, my name is Aleksandr Perevalov and I'm glad to see you at the ICSC 2022 conference. With a great pleasure, I would like to introduce you our joint work named QALD-9-plus, a multilingual dataset for question answering over DBpedia and Wikidata translated by native speakers. You can already access the dataset using the QR code on this slide. And now I would like to start my presentation. So, I will briefly introduce you to the question answering. Thereafter, I will present a typical architecture of a question answering system over knowledge graphs. It will help us to understand the motivation for a multilingual KGQA benchmark, which is the main goal of this work. Thereafter, the related work will be demonstrated. And after that, we directly come to the main contribution of this work, the dataset QALD-9-plus. I will describe the translation and validation process, the process of SPARQL query transformation from DBpedia to Wikidata, and the overview of the dataset. Finally, we will consider the evaluation on QALD-9-plus. So, modern question answering can be divided into two paradigms. The first is text-based question answering, which mainly works over unstructured textual documents, and the second one is knowledge-based question answering, which works with structured data. For example, SQL databases, document databases, or even knowledge graphs. In this case, we are dealing with knowledge graph question answering. Such systems map a textual question to a representation of a query over a knowledge base. For example, if we ask a question, in what city was Angela Merkel born, the corresponding query to DBpedia knowledge graph will look like this. And here on the slide you also can see some famous knowledge graphs. The architecture of a simple question answering system over knowledge graphs consists of several components. The first is relation detection. The relation detection predicts a relation or a predicate. In this question, the relation or a predicate is birthplace. Such component can be implemented using a language-specific technique or multilingual technique, for example, multilingual language model. The second component is name-entity linking, which recognizes and finds an entity in a knowledge graph. This component also can be implemented using language-specific or multilingual technique. And the last component, query builder and executor, uses the data from previous two components and is basically a language-agnostic component. So as I mentioned before, for the first two components we require some models or techniques to implement them. Modern natural language processing field proposes several weakly supervised methods, unsupervised methods, semi-supervised methods, which basically helps us to reduce our need in labeled data. However, we still need to evaluate our system, and that's why we require some very good quality labeled data to test the system. We came to the conclusion that it's not a fundamental problem to implement a multilingual system. However, the challenge is to evaluate it properly. While continuing speaking of the motivation for a multilingual benchmarks, we can observe the lack of non-English datasets. There are more than 7,000 languages spoken in the world, yet English dominates in many NLP research communities. It is also true for KGQA field. The languages you are able to speak affects your experience on the web. It was proven by many researchers. And here you can see a diagram of the number of textual datasets per languages on the website Papers with Code. And obviously there is a huge bias to English. It has almost 800 datasets. The second most popular language is Chinese, which has something above 100 datasets. Finally, the motivation for a multilingual benchmark is that even Google fails with some languages. We know that many researchers aim to the best possible quality on a particular benchmark, mainly using English language, and we also know that Google is quite precise with the English language. So here I asked the same question in 4 different languages. How old is Donald Trump? The first 2 pictures demonstrate us that the Google was correctly understanding my intention and it showed the typical structured information and the correct answer in the center for English and German language. However, for the two other languages, Belarusian and Bashkir, it didn't show any specific result, and even it said that it looks like there aren't many great matches for your search. Basically, these languages are spoken in total by more than 5 million people in the world, however, still no support by such a very popular search engine. Of course, the following important questions are often overlooked in the process of developing of question answering systems. How many people can really take advantage of high quality KGQA systems? Who are these people? How diverse are they? For example, are they living on one particular continent or not? And so on. We were capable to find only 3 multilingual KGQA benchmarks. So the first one is QALD-9, which is the most updated version of QALD series of datasets. It works over DBpedia and has 558 questions in 10 languages. The second dataset is Rubik. The latest version is number 2.0. It has questions over Wikidata in 2 languages and almost 3,000 questions. The most recent dataset CWQ contains 10,000 questions over Wikidata in 4 languages. However, we have to say that the last 2 datasets contain machine-translated questions. And the most recent, most fresh dataset CWQ also has artificially generated data. However, QALD-9 is also not perfect. In our preliminary research, we observed that the multilingual representations are not of good quality, and that's why we decided to improve this dataset in our work. The QALD dataset has also very flexible and convenient data format. It became a standard for KGQA datasets, and we also are continuing to using this format in our work. There are also not so many question answering systems over knowledge graph in multilingual setting for a past decade. Our assumption is that as there are not so many benchmarks, of course there will be not so many systems. Moreover, not all of these systems are accessible right now, and only 3 of them were considered for our work and for the evaluation: DBpedia, Platypus, and Q-answer systems. So now let's talk directly about the improved dataset for knowledge graph question answering. The first step is translation and validation. In our first step, we considered only English questions from this dataset as a gold standard. Thereafter, using crowdsourcing process, we asked the native speakers of target languages to translate these questions from English to their native language. The second step was the validation process. This is completely different step, and different people were participating in this step. So we gave to native speakers of a target language a set of the translations and asked them to select whether the translation is correct or not. Basically, the process was looking like this, and we were using the following crowdsourcing platforms: Amazon Mechanical Turk and Yandex.Talk. This is how the crowdsourcing task looks like. In this case, you can see also 2 questions in the beginning of the translation task. These questions were pasted only to Amazon Mechanical Turk because it was not possible there to restrict people with a particular language, which wasn't the case for Yandex.Talk, where we could actually restrict the crowd workers. For example, if we ask people to translate questions to Belarus language, then we of course restrict the region by the phone number from Belarus, and so on. The screenshot on the right side is the validation task. Basically, the coverage of our translations was allowing us to propose 2 translations to validate them. And the selection options were the following: none of the translations are correct, only first or only second translation is correct, or both of them are correct. Sometimes the translations were completely identical, which was not the problem. Thereafter, we transformed SPARQL queries from DBpedia to Wikidata in order to increase the usability of the dataset. However, it was not also a simple process. For example, here you can see a completely different basic graph patterns in DBpedia and Wikidata for question when did Finland join the European Union? In total, 51 of the DBpedia queries were not transferable to Wikidata due to the lack of corresponding data. However, for the other ones, we were capable to do it. In total, we obtained the following dataset. It has many translations in different languages, and it also has Wikidata queries in it. For example, for German language, we were capable to obtain even more translations that unique questions are contained in the dataset. So that means for one particular questions, there are more than one translation exists. The same is true, for example, for Russian language. However, for Armenian language, for example, we were not capable to obtain so much translations. However, it is the task for our future work. You can access the dataset under this link, and also some of the notes have to be mentioned. English questions were not changed here. Questions in other languages were completely replaced or the languages were completely eliminated. Not all the DBpedia queries could be transformed to Wikidata, as I mentioned before. 2 of the languages introduced in the dataset, Belarus and Bashkir language, are considered as endangered officially, and no KGQA data was ever released in Ukrainian, Lithuanian and Armenian languages, which is also a big contribution as we consider. Finally, the evaluation on this dataset was performed. We were interested to see if there is a difference between original QALD-9 questions and our improved questions. Surprisingly, there was no such big difference. For example, the difference was observed only for Russian and French languages, while for German languages there were no difference. Of course, we can say that these systems are robust enough to deal with bad translations and so on. However, on the other hand, we can also say that these systems are over-optimized to these questions, and that is why the quality is not different so much. In conclusion, I would like to underline the limitations of this work. The original English questions were not checked by native speakers. However, we as fluent speakers of English language could evaluate that, and we can say that they are of high quality and can represent the intention of the question itself. The validation process can be also improved. For example, we were not validating if the people that translated the dataset were not the same people that validated the dataset. Of course, there are many people on the crowdsourcing platform, but sometimes there could be intersections. Also, a very important question: does the community need such well-formed questions in the datasets? For example, when you paste something in Google, you basically don't care so much about the form of the question. That is why we consider adding simplified forms of the questions in the dataset in future. So, QALD-9-plus is a small but important step towards better multilingual KGQA. Our next steps are increasing number of questions, increasing number of languages in the dataset with a focus on low resource and endangered languages, and of course, more extensive evaluation on this data. But maybe the last future work task is not only for us, but for the research community. So, feel free to use this dataset for your evaluations. And if you have any questions, please contact us. We are open to answer them. Thank you for the attention.